Hi all. In this lecture, we're going to discuss 12 integration problems of different kinds. So I will make you understand each and every type of integration problem by different methods. Every problem will have a different method of solving. So make sure that you must follow each and every step of mine. So let's begin with the first problem. In this problem, we have two terms, and dx should be multiplied with each of the term. So we can write, it means that 10x cubed under root x dx should be integrated with respect to x. And also, in this case, 2 second square x, we have dx in front of it. It means that we want to integrate with respect to x for this term. Now we can combine this x cubed and under root x and we can write this term as it is. Now for integrating the first term, we need to take the constant terms, which is this, outside of the integral, and keep the terms which are depending on x as it is. Do it for this term also even. Now for integrating the x cubed plus half dx, we need to write the constant terms and integral as it is, like this. And you need to write x 3 plus half and add 1 to it to the power, and also divide this whole term by the power itself, and you are done. Make sure that you need not write this integral sign then. Okay, your integral is over. This is the answer for this first term. And for the second term, write the constant terms for this second terms, and the integral of second square x is equal to 10x. And lastly, you add a constant. This is your answer. And lastly, you may solve it for this power and evaluate expression. Let's take the second problem. In this problem, we have given a denominator having 25 plus x square. In such problems, we need to put x equals to 5 times z. Now differentiating both sides, dx equals to 5 sec squared z dz. Now substitute this equation and the following equation we get. Now take the 25 as common from the denominator. You can cancel out 5 from numerator denominator, you get. And also you may write 1 plus 10 squared z equals to sec squared z, and which is in the numerator. It means that both the terms would be cancelled. Now you may take the constant term outside of the integral, like this. Now you may solve this integral, because this integral is with respect to z, and we need to take the constant term out as we have already done. And this z is having a power of 0, we need to add 1 to it, and if we divide it by the 1 of the power, so it will be z to the power of 1 divided by 1. So it is same as z, and you need to write a constant in front of it. Now from the equation x equals to 5 times z, solve for the value of z. You will get 1 by 5 tan inverse x by 5 plus c. This is the final answer. So let me tell you one thing. We made a substitution of 5 tan z, because if 5 is put in this square, it will be 25, and this 25 would get outside as common. So you may write 1 plus 10 square z equals to 6 square z, and it may be cancelled from both the numerator and denominator. So that's why we made this substitution. And also, if you generalize this formula, you can write. You can note down this. Let's take another problem. In this problem, we have sine 5x dx. Here 5x is the argument for the sine function. It is a trigonometric function, and if we substitute 5x equals to u, then you can solve it. How? Let's see. Now you can differentiate both the sides. Now you can substitute the value of x and dx in this equation. Now this integral has been resolved with respect to u, and sine u du. Okay. Now what is the integration for the sine u? It is minus cos u. So you may write, okay, now you can substitute the value of u in place. And this is the final answer to this problem. Let's take this problem. We have x square, and in bracket we have x cubed plus 1 bracket close dx. And in this example, we have two choices to be done. Whether you can multiply x square in this bracket or parenthesis, and you can solve this anyhow, or there's another way of solving. There are two methods. Let's take the first method. And in this case, we have distributed the x square in the parenthesis for x cubed plus 1. Or you can do it by substitution. How? You can take this term x cubed plus 1 and substitute as t or u. Now you could have done this through differentiating both sides, 3x squared dx equals to u. We can put this in this equation and you will solve it. What if the problem would have been like this? You may not use that this distribution law to solve such problems. You may have to evaluate this one. In such case, the U-substitution is a better way to solve such problems. Put these two values for x and dx in such equation and solve it. And you may solve this problem with respect to u. I'll leave it for you. Make sure that you get this answer. Let's take another problem. In this problem, we have a square root in the denominator having 9 minus x squared. And in the numerator, we have 3x. Now, if we substitute x squared equals to t, then the problem will not be solved. For example, in this case, if we take 9 minus x squared whole equals to 3. In this case, if we take 9 minus x squared as a whole equals to t or u, differentiating both the sides, now you can substitute the value of x and dx in this main equation. And now this u in the denominator, we have the power of half, and if you take this u to the numerator, it will be minus half. Now you can integrate the integral with respect to u, and you can add 1 to the power, and you can divide the term with the power, entire power, and you will get something like this. Now you can put the value of u, and also this 2 will get cancelled out in the denominator, and the final result that you will get is okay. Now let's take this another problem. We have x squared under root 4 minus x squared in the denominator, and we need to substitute for this x squared. For such problems, you need to put x equals to 2 sine z as earlier stated, and you need to integrate the both sides, and it will be dx equals to 2 cos z dz. And now you put the value of x and dx in the following equation, and you will get this. Okay, so dx will be 2 cos zx. Okay, we are remaining with the 2. Here it is, 2 cos z dz, and we have the dx, which is 2 cos z dz. Okay, so the x equals to 2 sine z, so we have placed 2 sine z in place of x, so it will be 2 sine z whole square, and in the square root we have 4 minus the x square, and if we place 2 sine z in place of x squared, it will be 4 sine square z. And if you solve this equation, you can solve the denominator as like this. Okay, you can take the square root of 4, as well as you can write 1 minus sine square z is equals to cos square z, and this cos square z, if got out of the square root, it will be cos z, and it will be get cancelled from the numerator and denominator both. So you can cancel out this whole term with this. Now you can take the 4, this 4 which is 2 square, and you can take the 4 outside the integral, and you can write the sine square z to the numerator, which is second square z, and lastly the z. You can solve this problem like this, and the integral of cosecant square z is equal to minus cot z. Okay, so you can write the whole final answer as Okay, now actually the answer should not be in z, it should be in terms of x. So to convert this chord z in terms of x, we need a triangle. See, according to the equation, this equation, construct a triangle. This angle is z, and this is the right angle triangle. And also now see, sine z is equals to x by 2. Sine z is equal to the perpendicular upon hypotenuse. Now the perpendicular is this one, so it is x, and the hypotenuse is 2. By using the Pythagoras theorem, you can find out the other side, which can be written as, now you can find out the value of cot z. Now you can find the value of cot z from this triangle. Cot z is equal to base upon perpendicular. Now you can write cot z is equal to, okay, you may replace the cot z by under root of 4 minus x square divided by x, because it is based upon perpendicular. Okay, it is the final answer because it is in terms of x. Okay, I hope you have enjoyed this tutorial, and if you like this video, like the video and also comment below my video, and also don't forget to subscribe my channel. Also click the bell icon so that you can be notified every time when I upload a new video. So mainly in the next video we're going to solve these 6 problems. Okay, and if you want to watch this video, you have to subscribe my channel. Okay, thanks for watching.